All right, so when we are solving three equations, it's like when you're solving 2x plus 1 equal to 10, we do 2x equal to 10 minus 1. We do 2x equal to 9, x equal to 9 halves. That's what we do for linear equation, any equation that is solved. Now, it's a little bit complicated here because this is solving a linear equation, right? Solving a linear equation. Our equation is more complicated than that. It's going to have trigonometric functions, and you would be asked to do uh, uh, maybe at times you need trigonometric identities to be plugged in for simplification, right? So I'll just do just solving trigonometric trig equations is the same as solving any equation actually, except that it involves some trigonometric function. So there is no just guideline for it. We're gonna solve. It's actually isolating x or theta, whatever the variable is. So that's what you're doing when solving equations. All right. So examples would follow from the textbook. We're going to do solve some questions from the textbook. The questions are found on page 568. So the first question I want to do is number 6. Uh, so number 6 is solve for x. Okay, and x must be falling between 0 and 2 pi. Like they want radian measure, right? This is equivalent to saying 0 is less than or equal to x less than 360 degrees. Yeah, the same. So that means all I want is from here to here, right? You don't want to do 2, 3 circles. Only the first, or the first quadrant, second, third, and fourth only quadrants. I don't want any angle more than 360 degrees. That's what it means. Because otherwise you could add 360 to every angle, then the number of solutions would be infinite. Question number 6 states that solve 2x, 2 cosine of x plus 1 equals 0. Okay, so as you know, here is where my x is. Therefore, I have to isolate it. To isolate that, I have to get rid of this one. 2 cos x equal to negative 1. And then cos x equal to negative 1 half. And then this is where you have to analyze. You stop here. I know cos x is cos inverse of negative half, but that's not good enough for us, because if you do so, you only get one angle. You only get one angle. But there could be more angles, and then you will be like partially answering the question, not completely, not fully, right? So what I'm suggesting is, as soon as you get here, you analyze the question and you make the Cartesian coordinate system and analyze when is cosine negative. Cosine negative. You remember the cast rule? I know cosine is negative when x coordinate is negative. X coordinate is negative here, so it's here and here. Cosine is always x value in a unit circle. So the cosine is negative on the second and the third quadrant. So what is reference angle? Reference of x, I will call it x reference, equal to cosine inverse of ignoring the negative, which is 1/2. We used this in parametric curves when we were finding the angle of the force or the vector, what have you, right? Okay, what is that? Okay, so okay, somebody must have done it because okay, 60. What's in with some? I'm looking for a radian measure. So if you don't mind, change your calculator to rads because they said in between 0 to 2 pi. So you either change it. 60 is of course it's pi by 3, but I think it's better if you change our calculators into radians. If but in here it's easy. It's pi by 3, isn't it? Yes, pi by 3. Thank you. So then what is the appropriate angle on the second quadrant? Which angle are we talking? Theta is equal to, we know we have done this. This is pi minus theta reference, which is pi minus pi by 3, which is 3 pi over 3 minus pi by 3, which is 2 pi over 3. Okay, so for the fourth quadrant, the third quadrant angle is pi plus theta reference, which is pi plus pi by 3, which is 3 pi by 3 plus pi by 3, which is 4 pi by 3. So therefore, the angles x can have are 2 pi by 3 and 4 pi by 3. Okay. I know maybe it's too much extended, but actually this is actually the proper format of working it. You can cut the steps, as much as you can, but actually it's better for you to see it like this. So you will take it as usual. So I will do number 10. Question number 10 is the same instruction, but a different function. So I have 3 tan squared of x minus 1 equal to 0. So this implies 3 tan squared of x equal to 1. Tan squared of x equal to 1 over 3. Then what happens is, well, when it's a square, you have to do plus or minus. Tan x is plus or minus 1 over root 3, right? You take the square root of the right-hand side. Square root of 1 over 3 is simply the square root of 1 over root 3. So, I mean, what do we do then? Then x reference is, well, first of all, you have two functions. One of them states, this is where, because it's plus or minus, one of them is tan of x equal to 1 over root 3 positive. The other is tan of x equal to minus 1 over root 3. So you can classify them as such in cases 1 and 2, and then investigate. So what is reference angle? Well, tangent is positive in the first and third quadrant, because tangent is positive when x is plus, y is plus, or when x is minus, y is minus. Tangent is positive. Tangent is positive because this is positive. So therefore, here in the first quadrant, x and y are positive. In the third quadrant, x and y are negative. So we expect tangent to be positive. What is the reference angle? X reference is this angle, the one on the first quadrant, is tan inverse of 1 over root 3. You can use this. It's tan inverse of 1 divided by root 3 by calculator, or if you know the numbers, it's 0.52. I mean, in pi, it is 30 degrees, which is pi by 6, right? Yeah, pi by 6. So then x reference is pi by 6, which is, if you don't know how to get this pi by 6 from the calculator, actually you can use this 0.52 in 3 decimal places or 4 decimal places, maybe to make it more accurate. This is radians. That is the angle. So what is the third quadrant angle? This is an answer, by the way, because our angle also falls on the first quadrant. The third quadrant angle would be another x would be, this is x, another x would be on the third, which is pi plus the reference angle, which is pi is y pi plus pi by 6, you can call it, which is 7 pi by 6, or what is plus pi shift pi, which is 3.6652, is also an answer for it, for the decimal place. 7 times shift pi divided by 6, 3.6652. Okay, that is those are the two answers which are relevant to this scenario. What about this scenario? So x reference is, okay, tan inverse of, again, you ignore the negative. This is what you do. This is equal to pi by 6, right? So it is actually 0.5236. So where are the angles here? Where are the angles when is tangent negative? Tangent is negative when x is positive, y is negative, or when x is negative, y is positive. This happens on the second and on the fourth quadrant. X and y are opposites on the second and on the fourth quadrant. So once we get, so therefore x would be then, this is reference, it's not an answer for this, it's not an answer, it's a way to the answer. On the second quadrant, it is pi minus your reference angle. So pi minus your reference angle, which is equal to 2.60890, or in radians, pi minus pi by 6, which is 5 pi by 6. What did I mess up in my numbers? Yeah, pi by 6 is what? Okay, minus. I think this number is not right. Uh, 2.6180, right? Which is 5 pi by 6, right? Because I have students that have difficulty with expressing the angles in pi. That's why I'm doing this decimal and the exact numbers. The fourth quadrant angle is, of course, 2 pi minus reference angle, x reference, which is 2 pi minus pi by 6. Remember, reference angle is pi by 6, which is right there. So pi by 6, and then you got 12 pi minus pi, which is 13 pi by 6. No, 11 pi, because it would be 11 pi by 6, or in decimals, it would be pi minus, or whatever, yeah, pi 2 pi minus 0.5236, which is approximately equal to
11 by 12, I think, right?
By 6, because 2 pi minus pi by 6, right? So what is 2 pi? It is over 6. I want it over 6. It is 12 pi over 6, isn't it? Minus pi over 6, Wissam. So it is 11 pi over 6.
The angle is 330, right?
Huh? Yes. Yes, you're right. Which is 11 pi by 6, is not? It's 2 pi minus pi by 6.
I'm getting 11 by 12 because 330 divided by 3.
Oh, 11 pi by 12 is less than pi. It can't be 330 degrees. No. 11 pi by 12, if that's the answer, is less than pi. It's less than 180. It cannot be 330. The 11 pi by 6 is the right answer.
Okay. So since I said it's in the fourth quadrant, and
Yes,
we find the standard by 360 minus the reference angle, right?
yes,
If we are in the fourth quadrant, so
yes,
360 minus the reference 30 will be 330 in the standard form,
yes.
and
And equivalent radian measure is 11 pi by 6 for 330.
okay, so okay, thank you.
You can do Wissam, if you want to double check 11 pi by 6 means what? 11, you do change that pi into 180 and check if it's 330. Do it 11 times 180 divided by 6 on your calculator. Yes. So that's the right answer then, Supawadi, yeah? Okay, you get it? Yeah. So because we make the same denominator the same, so it must be the denominator is the common denominator, which is 6. It cannot be 12. Right? Okay. So I know I have a question from Michael maybe. Is either form okay? Yeah. Whether you give me in decimals or you give me in terms of pi, it's okay, Michael. Was that okay? Did you get my answer, Michael? Supawadi, thank you for your answer. You're right. All right. So this would be 2 times 3.14, which is pi, minus 0.5236 would be 5.75996. That would be the second answer. So for all this, to summarize your work, right? Summarize your work. Therefore, x must be 2 angles on the first scenario, which are pi by 6, 7 pi by 6, and 2 angles in the second scenario, which are, oh, not 2 angles. Yes, 2 angles. What did we get? 5 pi by 6 and 11 pi by 6. 5 pi by 6 and 11 pi by 6. Or in decimal, we got 0.5236. This is approximate, of course. And then 3.6652. And then we have 2.6180. And then 5.7596. Even, to double check, if you have the equation 3 tangent squared of x minus 1 equal to 0, what if you plug this in the x value here and the x value here, in the x value here and in there, they will give you 0. Definitely. If you put your calculator in a radian measure and then plug all these angles into this equation, that we say this satisfy the equation, meaning that what? If they satisfy the equation, they are solutions to the equation. So you can double check by plugging in. You can double check if the answers are correct or not. But if you use calculator, you will be limited. You most likely you will be only gonna get 2 answers instead of 4 answers. That will compromise the answer for the system. So you gotta use the mathematical way of doing it. Okay. Do we have time for one more question? Yes. Okay. Let's do like number 12. Number 12, sine of 4x minus sine of 2x equal to 0. So what we could do is, of course, I could change sine of 4x because this is in 2x. I can change this by identities. We learned that in section 3, which is double angle formula, which is sine 2 sine of 2x cos of 2x minus sine of 2x equal to 0. That's what we have. Remember, sine of 2 theta, this is the identity. Sine of 2 theta means 2 sine theta cos theta, right? So I applied because 4x is 2x plus 2x. So it's 2 times 2x. So I broke it in such a way. On the left-hand side, I see common sine 2x. And then I have 2 cos 2x left minus 1 equal to 0. So I can break this, if AB equal to 0, A is equal to 0, and B is equal to 0. So this must be 0. Sine of 2x must be 0. The second case is, so sine 2x equal to 0. The second case is 2 cos of 2x minus 1 must be 0, which is equivalent to saying 2 cos of 2x equal to 1. Cos of 2x equal to 1/2. So we're gonna solve. This is what we get, the scenarios, right? So now we have two cases. Sine of 2x equal to 0, and then cos of 2x equal to 1/2. Well, sine and cosine is 0 when it's in a quadrant angle. When is a sine 0? Can you tell me on the xy axis? When is sine of an angle 0? When the angle is 0 and 180. Excellent, right? So when the angle is 0 and 180. So therefore 2x must be 0 and pi. Then from here x must be 0 and pi over 2 because I got to divide by 2. You understand? That's considered. That's a quadrant. These are quadrant angles, so that's it. So what is cosine to x is equal to 1/2? Well, of course, cosine to x is 1/2. It's positive. So cosine is positive. Which quadrants? Yes. Which quadrant is cosine to x positive? It is on the first quadrant and the fourth quadrant. Cosine is positive. Cosine is positive when x is positive. When x is positive. Where is x positive? It's here, right? So therefore, it's the first quadrant. So 2x reference. What is the first quadrant angle? Is cos inverse of 1/2, which is equal to what? The cosine. What angle gives you cosine equal to 1/2? Okay, 60. Cosine 60 for 1/2, so it's pi by 3. So if 2x reference is that, then well, I don't have to call it reference like that. Well, maybe. Then what is this? 2x. X becomes then pi over 2. This is 2x reference equal to pi over 2. So therefore, x is pi over 6, isn't it? Yes, thank you. And then the next one is 2x would be then what? 2x is 3 pi, 2 pi minus your reference angle, which is pi by 6, which is equal to 12 pi minus pi, 11 pi by 6, right? When you make them of the same denominator, 12 pi over 6 minus pi over 6 is 11 pi over 6. But I want x. X is 11 pi over 12. So I have the following angles as an answer. Therefore, x must be 0, pi by 2, pi by 6. Okay, I will write pi by 6 first because it's smaller, pi by 2, and 11 pi by 12. We'll do all these answers. Is that true? Can we check? Like, can we check sine 4x minus sine 2x, sine of 4x minus sine of 2x? Is it equal to 0? Is it equal to 0? Let's plug 0. It is x, yeah? Yes. Let's double check. Sine of 0 minus sine of 0, of course, is 0 because sine function is 0. X equal to pi by 6. Sine of 4 times pi by 6 minus sine of 2 times pi by 6. With a calculator, you can do it, you know. This is 2 over 3 pi. Is it really 0 is a question. These are yeah. Yes. I got 0. I don't know. I hope you got 0. Yes, 2 over 3 minus 2 over 3. Arthur, thank you. And then we can continue. I'm sure they will be true. If x is pi by 2, you will get sine of 4 times pi by 2, which is 2 pi, which is 0, minus sine of 2 times pi by 2, which is pi. Sine of pi is 0. So I know this is true. If x is equal to 11 pi over 12, then sine of 4 times 11 pi over 12. You can even use calculator. I'm using calculator because I don't remember a lot with the exact numbers. So sine of 2 times 11 pi over 12 must be 0. Oh, it didn't give me that. Did you get it? No. No, yeah, Arthur. Yeah, so what did we mess up with? So 5 over 6 pi should have been the answer? Is that what you're saying? Yeah, okay. Let me double check on my work. And how? 2x is 2 pi minus pi by 6. The reference angle is pi by 6. No, the reference angle for 2x is pi by 3. See, that's the mistake. This is the reference angle, not x. So pi by 6 is not the subtraction. It must be pi by 3. Before we divide, we have to take away pi by 3. Yes. So that's the answer. I used the wrong reference angle here. X is an answer, not a reference angle. Reference angle is this one. Before we divide, okay? Thank you so much, Arthur. So this is equal to 2 pi over 6. So 2 pi minus pi by 6. Not pi by 6, it's pi by 3. So I'm going to multiply it. To change it into 3, I got 6 pi over 3. So it would be 5 pi over 3. Yes, that's the answer. So therefore, x from here, then x, therefore, x is 5 pi over 3 divided by 2, which is 5 pi over 6. That must be the answer. The fourth answer, the fourth value is 5 pi over 6. So I used pi by 6, which should not be. That was the answer, not the reference angle. So this is truly 5 pi by 6. Sine of 2 times 5 pi by 6 must be 0. Yeah, that's true, and all of them are correct. So this is not 11 pi by 6, it's 5 pi by 6. Okay. Yes, Arthur, 5 pi by 6 is a better answer. The reason, do you see the mistake we made, Arthur? Why we got the wrong answer is because we plugged in the reference angle. Yeah, we plugged in 5, pi by 6, which is not. That's the answer after it's divided by 2. But the reference angle is pi by 3. I will stop here. If you have any questions, I will answer. So they get a little bit harder when they give you quadratic equations and so on. They get complicated at times, if you go further, maybe I will do next class. I will do start with one harder question where we have to factorize the trigonometric identities and so on and so forth. So we are technically done in chapter 20. These are the trig identities that the Rafael. So yes, have a great day. Thank you, Rafael. So what was it Rafael who was asking me about time before? Rafael, are you? Catherine, yes. Rafael, were you the one who asked me about time? Am I right?
I think Nick too.
Yeah. But what I could do next test is I probably give extra 5 or 10 minutes. But what I tell you as a reason is for me, it is actually very reasonable to give the time I'm giving for this type of tests. Okay.
Sir, for me, like the internet wasn't good, so I spent like more
That
than
is a
10.
special case, Rafael. That is
Yeah,
a special case.
yeah, sir.
You
So
should
that's why I
contact
just
me
wanna tell
if there is a
something.
problem.
I just
Oh, go ahead.
I uploaded mine like at 12 20, but it's like reached at 12 at 22.
Sorry.
The time was, sorry, not 20.
12. Yeah. So
Yeah,
no problem.
sorry.
Can I answer that question?
Yeah, because I just like it takes 2 extra minutes to upload.
Yeah. Yeah. Okay. Let me ask you. Let me answer that question. I know when you guys are writing like the test. You know how many emails I get of help when there is a problem like that. You should contact me. I don't, but I cannot say, oh, add more time is not a right question. If you have a problem in downloading, or if the system crashed, or if there is some, extraordinary thing going on your end, you have to email me. I'll help you. I will be happy. Like if you say, okay, I can't download it, there is a big problem in my computer, so could you help me? Then I will discuss with you what I can do. That is a special case. But really, the test, the questions I make with the practice test, with the questions I did, I give you more than enough time, I believe. But even I added, normally I wanted to finish at 110, but I added 10 extra minutes and made it like 120. I mean 11:20 to finish. You know what I mean? So in my end, I thought I added more time for this test. But anyway, um, we all of us cannot have the same speed to do the things. Sometimes you only can judge the test overall. Just because you can't do one question, if you do all of them with better work, you shouldn't care. You should really evaluate the whole. I think personally that's what I think. When you evaluate the test, evaluate over all the tests, how you did. And at the time, to tell you the truth, in every class I taught calculus, every one of my tests are 50 minutes, and then the extra 10 minutes in class before a teacher comes, I ask the teacher, can I let my students finish, and then I give them 10 extra minutes. That's all. So most of them tests were 3 pages, but I'm making this test like less than 3 pages. Even though I gave you 3 pages, there was a lot of uh, a, a lot, yeah, there was a lot of space. Otherwise, it could be condensed into 2 pages normally. But I didn't want you to bother by not having enough space, so I spread them a lot. Thank you, Wissam, for the comment. I thought some of you might have finished in half an hour for this test, or maybe 45 minutes. I don't mean, Rafal, your question is not right, but your question is right, but try to improve the speed of the writing the test. And if there is extraordinary thing like downloading problem, you let me know. I'll add what I can do. You know what I mean? Individually, not like don't really. I mean, I don't see the reason we have to add more time because it's online. There is no reason. Actually, the conditions are more serious when we are face to face. We have no exposure to any material. We have no exposure to your notes, whatever. Have you? I mean, it's more serious when it's face to face. And then I ask my students to finish in 15 minutes. So how is that hard to finish in an hour and 20 minutes? I think so. But like I said, what I can add finally is just let me know if there is any problem. Catherine, sir, like 10 minutes more will be helpful. We will consider it next, Catherine.
Okay, thank you.
But it depends on the test. If the test is very short, I will stick with it. If the test is a little bit longer, I will add 10 minutes.
Sir, actually, I like your questions because like it is really for students and it is reasonable and we can solve it. But sometimes like we just need to think. We can't like memorize the math. It is like thinking. It is about thinking. So when we
Yes.
the question, we need to think before we do the first step. Like we can't just solve it because we don't memorize it.
If you so listen, Rafal. If it's okay, I think we should disconnect this